In this video, I will be discussing what computational thinking is and how teachers can develop these ideas within school. In 2013, the new computing curriculum was introduced, which aims to bring together the ideas of computer science, information technology, and digital literacy, as well as provide opportunities to develop computational thinking skills and creativity, which children can use to understand the world. Computational thinking is an approach to solving problems in a way that can be implemented by a computer. We use computers to help us solve problems that we would not be able to solve otherwise, but to get computers to help us, we must first think about the steps that are needed to solve the problem, then use technical skills to tell the computer what to do. Computational thinking applies to the first step, where we must first understand the problem in order to solve it. Berry suggests that computational thinking is made up of different processes, including logical reasoning, algorithms, decomposition, abstraction, pattern spotting, and generalization and evaluation, although additional processes such as debugging, tinkering, persevering, and collaborating would all be important skills to use when trying to think critically and solve problems. It is not only in computing that we are required to solve problems, so the processes encompassed by the term computational thinking can be developed in all areas of the curriculum. When children enter the early years, computational thinking can be developed through the activities provided by the teacher and the everyday classroom routines. Following rules, working in groups, and playing with toys are all good ways to develop a working understanding of algorithms, collaboration, and debugging. Logical reasoning can be developed by asking children to justify their thoughts or ideas, something which is constantly done within the nursery and reception classes. These skills could also be developed when using technology. In the early years, children are expected to complete simple programs on a computer and use hardware to interact with age-appropriate software. So the use of computers, iPads, and Bbots in an early years classroom could be beneficial to allow children to develop computational skills and expose them to different types of technology. In Key Stage 1, children can continue to develop computational thinking processes without the use of technology. For example, in their writing, children would have to logically justify their ideas, go through the step-by-step writing process, then tinker and debug their writing for any spelling mistakes or grammar errors. In maths, they would begin to spot patterns in number and shape and be able to generalize rules. In geography, they would decompose continents into countries, and in DT or PE, they would have to follow algorithms or instructions to achieve a particular goal. In the new programming curriculum for Key Stage 1, children should be able to understand, use, and create algorithms, and to create, debug, and predict what simple programs will do. This can be encouraged using apps such as Daisy Dinosaur or Scratch Junior, which prepare children to use Scratch in later Year 2 and Key Stage 2. Scratch allows children to develop their creativity and computational thinking skills by letting them create their own codes and games. Children would have to use logical reasoning to predict what would happen when they choose a code, use clear, unambiguous algorithms to tell the sprite what to do, decompose the problems into smaller problems, generalize and spot patterns within the code, and tinker and debug anything that goes wrong. The blocks are easy to put together and easy to pull apart, which can encourage children to persevere and try different ideas, which can develop their confidence when using computers in general and when completing coding. In conclusion, it is important that teachers develop children's computational thinking skills so that they can be applied to any problem-solving activity across the whole national curriculum and develop children's critical thinking skills. I would aim to develop these skills from an early age by giving children the opportunity to solve problems both using technology and not using technology. I would model how children can use the skills of logical reasoning, algorithms, decomposition, pattern spotting, debugging, and persevering in any task, which would develop their understanding of these concepts, which can be applied to programming and problem solving in later life.